Hey guys, Jay Bish here, and welcome to another episode of Chem Nerd Content, your daily dose of chemistry-related classroom content. I'm using the word content quite a bit. Hopefully these quarantine videos are useful for you guys. I've got some great videos planned. Some of them aren't even chemistry related. I just hope that you guys are able to engage with it. Hopefully it makes it a bit more interesting. And I'm going to try and include some other jokes in here as well for you.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't.
For today's lesson though, we're going to be talking about redox reactions, reduction and oxidation. About reduction and oxidation type reactions. This is in chapter 10.2. Recall. Oxidation is defined as the loss of electrons, and reduction, on the other hand, is the gain of electrons, or a reduced charge. Oxidation and reduction reactions actually happen in conjunction with one another. So as one thing is getting reduced, another compound is getting oxidized. In this lesson, we're going to be covering 4 simple oxidation type reactions. Those include reduction of primary and secondary alcohols, chemical tests to distinguish primary, secondary, and tertiary alcohols, and oxidation of alkanes and alcohols by combustion. We're also going to be talking about 2 different types of reduction type reactions. Those are reduction of alkenes and reduction of nitriles. Let's jump straight in and have a look at reduction of primary alcohols. First of all, what is a primary alcohol? Primary alcohols are those organic molecules with a hydroxyl group that is up at the end of the main chain. So this is one at the end of the main chain, not anywhere in the center, the end. When you oxidize a primary alcohol, you are removing 2 hydrogens. These form an aldehyde. Further oxidation results in the formation of a carboxylic acid, like this one pictured here. Next up is oxidation of a secondary alcohol. Now the secondary alcohol is the hydroxyl group that's attached somewhere in the center. Oxidation of a secondary alcohol results in the loss of 2 hydrogen atoms in the center, forming a ketone. This ketone cannot be oxidized any further. Let's flip over and try some chemical tests to see whether or not we're dealing with a primary, secondary, or tertiary alcohol. Now, if we're looking at primary alcohols are actually able to be oxidized twice. So that means that there is 2 chemical changes. There are 2 different color changes that are going to occur. A secondary alcohol will only be able to be oxidized once, and a tertiary alcohol cannot be oxidized at all. So, if there's no change, easy, you're actually dealing with a tertiary alcohol. If there is one change, if there is a change when you start to test that alcohol, when you have that indicator in the alcohol, you'll find that it's either going to be a secondary or primary alcohol. If you try the test again and it oxidizes twice, so the color changes twice, you're actually dealing with a primary alcohol in this case. Some of those key indicators we can use include potassium permanganate, which goes from purple to manganese dioxide, brown, when it oxidizes. Potassium dichromate, orange, to chromate, green, or a Benedict solution with copper sulfate, blue, to copper oxide, bright red. Basically, you can use any one of these to indicate whether you have an aldehyde or ketone. Once oxidized once, add one of these indicators, and if the color changes, you are dealing with an aldehyde and you now have a ketone. If there is no change, you are dealing with a tertiary alcohol. The final oxidation type reactions are those of alkanes and alkenes through combustion. Simply put, the idea is to react alkanes and alcohols in excess oxygen. You can speed up the reaction by adding in heat. When alkanes and alcohols are combusted, carbon dioxide and water are produced. Finally, and super short, is the reduction type reaction. Whenever oxidation occurs, reduction is happening on another part of that organic molecule or another organic molecule in that equation. For alkanes, alkynes, and nitriles, you're able to reduce them by flooding them with hydrogen at super high temperatures, like 300 degrees Celsius or higher, and super high pressures. The alternative is that you can actually just use a metal catalyst like nickel, platinum, or palladium. That's the extent of redox reactions we're going to be covering for today. Feel free to grab those notes from Canvas and re-watch this video for some more of those visuals that are either floating around me or that have been screen recorded from the iPad. And as usual, please jump on and check your learning questions. Once you guys have watched this video, please drop a comment down in the discussion box just so I know you guys are participating. Okay, I will be monitoring that discussion box. I do get emails whenever someone does drop a comment, and feel free to drop a like on the video on YouTube as well. Let me know if you have any feedback, and until next time, keep safe, keep healthy. Peace.